Hello and welcome to Organic Chemistry 1, where we're looking at polar reaction mechanism. Remember, reaction mechanism involves stepwise explanation or logical steps taken starting from the reactant until you arrive at a final product. There are two types of reaction mechanism. In polar reaction mechanism, number one, it involves electron pairs. So that means two electrons are moving at the same time. And because of that, it involves charges. So you could either have a positive charge or negative charge intermediates. Number three, because it's two electrons, you have to use what's called a full-headed arrow. So a full-headed arrow will look like that. So the full head means two electrons. Half-headed arrow is like that, and that involves one electron. Okay, now I'm going to give you a reaction between an alkene plus a hydrogen halide, so I'll call it HX, and that will give you an alkyl halide product. So for example, if we have this alkene plus hydrogen bromide, and then that will add the hydrogen bromide across the double bond so that the hydrogen adds to the carbon with the most hydrogen. So you end up with the hydrogen there, while the bromide will add to the other carbon that has less hydrogen. In this case, no hydrogen. And that's the product. So that is the reaction. Next, the mechanism. In the reaction mechanism, we start with the double bond plus the hydrogen bromide, and we want to show that bond because we're going to break that bond. Next, this alkene has a higher electron density, and therefore it's going to be a Lewis base. Remember, Lewis base donate electron pair. That means it's actually a nucleophile. So you draw an arrow starting from the nucleophile to this hydrogen, which will be an electrophile. So you draw an arrow from the double bond to that hydrogen, and as you form a bond using this carbon with the hydrogen, at the same time you will break the carbon-bromine bond, and you end up with this intermediate. Now we just formed a bond to the hydrogen, and we broke the bromine, so Br minus. But this other carbon that lost the double bond now is empty, is electron poor. And because of that, we put a positive charge on that carbon. So it has a formal positive charge right there. And we call that a carbocation intermediate. So this is actually step one. That's the first step of the mechanism, formation of the carbocation intermediate. Step two, you could either use this, you can bring the whole of that here and use it for step two, or you could just draw an arrow from there and that becomes step two. So in this case, we'll just use the arrow, and what's going to happen is that now the Br minus intermediate will now become the nucleophile for step two, and because of that, it's going to attack the carbocation intermediate, which will be the electrophile for step two. So we're going to draw an arrow from the Br minus to the carbocation, and therefore that will give you this product. And now we're adding Br to that carbon. And that is the final product, which is similar to what we have here. Now, one thing I would like to mention about the stereochemistry, and I'm going to use this intermediate, so I'm just going to copy this and use it.